All right, hello. Today we're going to go through an introduction to FRC programming. As a reminder, in the past we did a high-level overview of VS Code. There's some instructions here for downloading it and installing it if you haven't yet, as well as the video from the day that we went through some of the high-level stuff. And then a little more than a week ago, we did an introduction to Java in a browser-based compiler for Java. We used the slides from training.spectrum3847.org, or you can watch our video where we went through those slides as well. Today what we're going to do is we're going to actually have an FRC program running. A very simple, straightforward one that hopefully can function as a sandbox or a playground for you to start messing around with your own code and modifying things and see how it works. Again, I'm stealing a concept from Spectrum's training, so if you want, you can go directly to their slides or watch their video. Alan goes through it in a little bit more depth than what I plan on going through today. So if you want to get a little bit deeper into it, then that would be a great thing to do. But what we're going to be doing is modifying some code for a 2020 EveryBot. So let's take a look at that video real quick. I've got the link up here. Basically, this robot was designed to play the 2020 game, which was collecting these yellow balls. It had a couple of different motors, but it was overall a very simple robot. So there's a motor that puts the arm down, a motor that spins that black roller that sucks up the yellow balls, and then a motor that moves the climber arm up and down here. And then, of course, a drivetrain to drive around. We can maybe skip ahead real quick to the climber so that you can see what's going on here. It may actually look like it's going forward or one direction and then down. It actually ends up going the same direction the entire time, but that's more than we need to worry about for now. But either way, you can see the climber in action here, and maybe we would want a capability for it to go both directions. So what we're going to do is we're going to create a new project from template, specifically a timed robot, and then we're going to replace the contents of the project that it generates with the code that I've got linked here. So we'll go ahead and do this in a couple of steps. So if you go into your VS Code, you might already have another old project open. That's totally fine. You can go, you'll want to use the WPI command palette, which is this hexagon with a W in it in the top right hand corner. So you click that, and you can either select the create a new project, or if it's not up to the top, you can start typing in create new project, and it'll bring that up as well. So like I said, we want to select a project type. We're going to select a template, and then we're going to do it in Java, and we're just going to be doing a timed robot. You'll want to select a folder where you can put your programming projects. It doesn't really matter too much where you do it. You can do it in your documents folder. I've got one specifically for documents first and training. So I'm going to select that folder, and I'm going to call this EveryBot tutorial. We'll call this 2021. We pretty much always want to have this check mark to create a new folder. And we're going to put our team number as 5414. Because we are doing simulation, we're going to enable desktop support and then generate project. And if you do it in this window, it's going to close whatever project is already open. If you do it in a new window, it will leave this project open and open up a new window for the current project. We're just going to do it in the current project because we don't need, or the current window, because we don't need the project that's already open. So go ahead and pause, get your template project done. And now that you have that done, hopefully you can expand under source and Java and see that you've got two files here, main.java and robot.java. What we're going to do is I'm going to give you some code to replace all of the code in here. So if you want, you can go into robot.java, select everything in here and delete. And if you go to our slides, there's a link here. And if you open that up, it will be the robot.java code I want you to put in here. So you can either download it. I'm just going to select all the text in here. Be careful to not Control A. If you Control A, you'll see that it gets like this robot.java up here, and that's not what you want. So you want to just get the text in here, Control C to copy, come back here, Control V to paste, and then if you hit Control S to save, you should now have a new project here. We're going to do the command palette, and we're going to make sure that it builds. And you can see that in this terminal window here, it's executing, and now it says build successful in 4 seconds. And so go ahead and pause and make sure that you're able to get this to build with the new code. Okay, so assuming that you've done that now, once the project is open, you should be able to open the robot.java. And then what we're going to do is we can jump right into simulating this code. For the video here, I'm going to walk through a couple of things in the code real quick that aren't in the slides. If you recall from our introduction to Java and the browser-based Java stuff, we had variables that we would declare. So these are all variables, controller, and instead of being an int or double or anything like that, it is of type joystick. Same thing with this left motor and right motor. Instead of being an int or a double or boolean, it's a Victor SP, things like that. And these are those constructors. So we have to declare a new instance. This is the object. So this has a whole class associated with it, and we are giving it a channel of 0 or a channel of 1, things like that. You don't have to worry too much about how these objects work in particular. We're going to go more in depth into that later. You just need to know that you now have these motors, you have a drivetrain, and you have a controller for your joystick. These methods here, they've got fairly descriptive names, but there's also comments that describe what it is that's going on. So robot init, it runs one time whenever the robot is first started. And then robot periodic is going to run every robot packet no matter the mode. We don't need to have anything in there. Same thing with teleop init. Truthfully, we could delete these functions if we want to, and that would be fine. And then teleop periodic makes it so that whenever we are in teleop mode, we are going off and doing the thing. So we've got drive.arcade drive, where we're getting the raw access 0 and 1 from the joystick, and then mapping it to our arcade drive. So if we hover over this, you can see that the first parameter here, double x speed, is the robot speed along the x-axis, where forward is positive, and then rotation, which tells the robot how much it wants to rotate between -1 and 1. And then we've got some if-else logic here, where if a certain button is hit, a pneumatic is set to either true or false. The pneumatic is either going to be extended or retracted to put the intake up or down. And then again, we've got some buttons here to make the intake motor either go forwards or backwards. And if nothing is happening, then we stop the motor. And so that's all the teleop code. So go ahead and pause and look through that if you need to better understand what's going on. Okay, the next thing we're going to do is we're going to click on that hexagon with a W. That's the WPI lib command palette. And we're going to simulate. So you can type in SIM if you need to bring that up. And it's going to build for a moment or two. And then you're going to have this other thing pop up asking you to pick extensions to run. We want to select the HAL Sim GUI. HAL stands for Hardware Abstraction Layer, and we just want to be able to add that stuff, that extension. So once that loads, it takes a little bit for it to get through all of this. And you'll see that we've got some things that have popped up here. Yours may not look exactly like this. There may be some things missing. But the thing that I want you to note is that you can always bring these things up. A lot of these are, if there's a check mark or not a check mark, it means it's either open or not open. So I could select this PWM outputs, and it would bring that up, but we don't need that. What I do want us to bring up, though, is under the live window ungrouped drive, and then under network tables, live window ungrouped intake motor. And so you'll see that we have a representative of the robot here saying how fast motors are going and if it would be turning or going straight. And then a number here that is how fast the intake motor is going. Along the left-hand side here, we have these system joysticks, and we've got keyboard 0, 1, and 2. If you have your own Xbox or PlayStation USB controller, you can plug it in, and you can use your Xbox controller instead if you want to. I'm just going to use a keyboard. I assume everybody will have a keyboard at home. So I select keyboard 0 and drag it over to put it into the joystick 0. And you'll see that now I've got keyboard 0 with axis 0, 1, 2. And these little yellow squares are buttons down here. It might be important to note that if you go under driver station, keyboard 0 settings, this is where you can change how all of it functions. So you can add more axes to your keyboard 0. You can see that for axis 0, increasing it is the D key and decreasing it is the A key. This is how fast it increases or decreases, is the key rate and decay rate. We're only going to need to worry about axis 0 and 1, because if we go back to our code, you can see that I use 0 and 1 for driving the robot. So if we go to our simulation, we need to know that A and D is going to make the robot go forward, and S and W is going to make it rotate. And then we can also know that we've got buttons associated. So we've got buttons 1, 2, and 4, which are going to be keys Z, X, and V are our buttons. We can close that. Even with the robot disabled here, if I hit the A key on my keyboard, you'll see that this pretty quickly increases to -1. If I hit the D key, it increases to +1, and when I release it, it goes back to 0. You can change these settings in the keyboard settings. So if I wanted it to increase or decrease a little bit slower, I could change it to, say, 0.01 instead. And now when I hit the A key, it takes longer to get to -1 and longer to get back to 0. So the thing that we'll want to do here is this robot state. It starts off in disabled. We can't do anything. Once we put it in teleoperated, then the code that's in that teleop periodic starts getting executed. So when I hit teleoperated and then I hit the A key, you'll see that the robot starts going forward. And if I hold down the A key and hit either the W key or the S key, it indicates that the robot would be turning. And so you can do this and kind of mess around with your robot and see how it would respond. I'm going to change my keyboard settings back to what they were of the 0.05. And so you can see how it responds to these various things. You can also see that if I hit the Z key, it changes the output of the intake motor to 1. If I hit the X key, it changes it to a -1. And it does it instantly, just because of the way that this simulation works. In real life, it wouldn't be instant, but we're not trying to simulate the slow ramp up of the motor. That would be a thing for later. I'm going to put this back into disabled. Go ahead and pause, get things set up where you can run that. Okay, and now that assuming you've done that, I'm going to get caught up here. So we've executed the HAL sim. Simulation roughly looks like this. I've got some instruction slides here on how to add the drive motor and intake motor and dragging the keyboard over to the joystick and modifying the default keyboard settings. All right, so that is all that I want to show you. And so now what I want you all to do is to take a little bit of time to try to modify the code. So you can leave the simulation up and running, but whenever you make a change, if you want it to rerun, you can either hit the green arrow here to restart it, or you can hit stop, and then rerun it from the WPI-lib command palette, and it'll bring it back up. And it should save all of your settings on what kind of things you had up or not in the thing. So let's bring this up. All right, so yeah, you can see that it still has the drive window and all that. So some of the things that you might want to try messing around with would be you could maybe mess with how the controller works. So you could maybe make it so that instead of a -1 here, maybe it's a +0.5 or a +6.5. And what does that do? How does that change how the robot responds? Or maybe you multiply this side by a number, and what does that do? Another thing that you can mess with is that I want to point out that when I'm in teleoperated here and I'm running this, I'll even pull up a plot just so that it's a little bit easier to see. So I've got a plot, I'm going to add plot, and I got to remember how to, let's see, oh, I have to do it from here. Give me just motor, intake motor, and value. Okay, so you don't need to necessarily worry about how to add that plot, but you can if you want to. So when I hit, there we go. How do I, there we go. So when I hit the Z key, it goes to +1. And when I let go and hit the X key, it goes to -1. What happens if I hold down the X key and hit the Z key? It goes up to +1. What happens if I let go and now I hold the Z key and now I hit the X key? Nothing happens. And so why is that? Because if we hit the X key and hold the Z, it goes to +1. If I hold the Z and hit the X, it stays at +1. So why is the Z key a priority? How would we make it so that the X key was a priority? So that would be an exercise, and that has to do with this logic in here. And how would you maybe modify it so that it takes whatever is the newest button input, regardless of anything like that? So you could get some fancy stuff here, overriding it. Realistically, that shouldn't be a thing because hopefully our driver, isn't trying to give multiple commands to the same thing at once. So go ahead and pause and maybe just mess with that, see what happens if maybe you change the order of the if-else statements here. And then the other thing that you can do is I'd like to see y'all add a climber. So we have a Victor SP for the left motor and right motor of the drivetrain. So as you can imagine, you'd probably have to add a Victor SP for the climber motor. And you would want to follow this format here, except instead of a 1, it's going to be a 2. And we can use 2 because the intake motor is using 3. If this were 2, you'd have to make the climber be 3. And then you'd want to add to the sendable registry, copy this format and add the climber. And then in your teleop periodic, you'd want to add some if logic for making the climber go using a button. So go ahead and pause and try that and see if you can get it to run in simulation. Okay, hopefully you've paused, and I'll go ahead and go through adding this real quick. So Victor SP climber motor equals new Victor SP2. And then I want to add it to the robot init. And then I want to add some logic here. So I can do if controller get raw button 3. I could say climber motor dot set. I'm just going to make it go half speed. And then I could say else climber motor dot set 0. So hopefully that should be enough. So let's go ahead and give that a shot. So I'll want to add my climber motor. And when I go into teleop, now if I hit button 3, I see that it goes to half speed, and then when I release it, it stops. Now what happens if I wanted to make it go the opposite way? I'd have to add another button, so then I'd have to go driver station keyboard settings, and I could come here, I could add a new button, and I could make it be attached to B. And so that's button 5. So I could come in here and I could add a else if controller get raw button 5, and then I could make it go minus 0.05. Whoops, just minus 0.5. And then I might want to, I have a red squiggly line because I was missing a parentheses, and then I might want to go else climber motor dot set 0. So I could restart the simulation. And my climber is still down here, so I'll go into teleoperated. I hit C and it's 0.5, and I hit B and nothing happens. So why is that? Joystick button 5 on port 0 not available. Oh, you know what? I need to let's see, how do I? So it didn't automatically save it. Yeah, it didn't save it. Let's hit B. There we go. All right, so now when I hit B, it gets negative 0.5 and positive 0.5 when I hit C. So that's it for today. You can add additional things if you want. You could try adding a sensor to make it so that the motor stops when a sensor is there. And we'll expand on some of this this weekend as well. Thanks.